Greetings, everyone. This is Shadab here, one of the co-hosts of the your favorite show, the AI Files. This is a show that we actually help you catch up on all the AI news for the past week, including the AI and even the robotics, etc. Anything intelligent, essentially that we cover. And this is the only show that you'll also find a dedicated section for Azure and the Microsoft related section, particularly because both Jamie and I we actually work for the Microsoft here. But pass it over to Jamie now.
Sounds good. Thanks, Shadab. Hello, everybody. It's Jamie Basilico here, one of the other co-hosts of the AI Files. We've got a long history doing data and AI. As Shadab mentioned, I work here at Microsoft. I've been here for just about 25 years now and worked in this field for a little over 35, 36 years at this point, but who's counting? Just one other quick word. Please note the topics and the opinions that Shadab and I provide in this series is not an official Microsoft channel, so the views and opinions expressed by myself and Shadab are our own and do not represent the views of Microsoft. So with that, we have a lot of good topics to cover today and a couple quick demos as well. So you want to get right into it, Shadab? I think you got a quote of the week for us too.
Yes, we actually have the quote of the week, and it's a little spicy one this time. So, Jamie, this was actually a pretty happening week again. AI never disappoints. So we had we'll talk about the Nobel wins, the unprecedented and historic two wins, which were directly related to the AI. And as part of that, Geoff Hinton, who is often considered the godfather of deep learning, he was actually given one of the Nobel Prize. We'll talk about that later, but he was given a Nobel Prize in physics. And after receiving that, he actually said in one of the before the press release, he said that, which is the quote of the week for this episode, is he said, "Quote: I'm particularly proud of the fact that one of my students fired Sam Altman." Unquote. So this was using that opportunity to actually throw a mic drop moment. Basically, what he's referring to is Ilya, right? So Ilya Sutskever, he is actually the student of Geoff Hinton. Ilya was the chief scientific officer at OpenAI, and he infamously last year actually was part of the coup, you can say, which actually which unsuccessfully tried to remove Sam Altman from the CEO position and OpenAI board, which of course got reverted, and even Ilya actually is supposed to have reverted that position, and then he started supporting Sam Altman. But I think that rift never went away. Right after 6 months, he actually left. So just a quick context there, and that's what Geoff Hinton is actually referring to. Now, Geoff Hinton, the question is, why is he actually saying that? And the reason for that is the Geoff Hinton, who has in fact. That's why he was given this Nobel Prize, because he created this self-learning, deep learning neural networks, things like backpropagation, which actually helps the model learn. And that's why the AI has. So all that we see today kind of credits back to the work that Geoff Hinton has done. And ever since, however, and then his company was actually acquired by Google. And then he worked at Google for quite some time, but last year he actually quit because he wanted to voice his concerns around the AI safety, and which he thought wasn't going to be too good when he was working at Google. He's actually currently a professor at the University of Toronto. So again, I mean, I think it just highlights how the dynamics in the AI worlds are happening, Jamie. Where Jeff Hinton is kind of like getting in like conflict with Sam Altman. So OpenAI, he thinks that the OpenAI or Sam Altman is kind of uh, compromising on the safety aspects. In like basically it's a conflict between safety and the shipping, and that's what he feels, that the safety is being compromised, and his own concerns have been that the AI's capability of the current language understanding is actually far more deeper than what people even know about it. it is, in fact, he has raised it as an existential risk. So, something that reminds you of like Alfred Nobel, who actually invented dynamite, kind of regretted it, and then he instituted this Nobel Prize, right? Kind of like a redemption act.
Yeah.
Seems like Mr. Hinton is also on the same path. Like he's like kind of maybe um, regretting it, and now he's trying to actually correct the wrong in a way that, okay, highlighting the risk. But he's not like going all out to say that, okay, don't use AI at all. He's kind of like ensuring that, okay, there is enough safety, because he has a deeper insider knowledge about things, and he feels that this could be really an existential risk.
Yeah, it's certainly interesting. I mean, there's a lot of interwoven people and relationships that go back decades, and it's I look at it as, how is that impacting companies, their direction, intelligence, and overall security. So the more you dig into it, you realize the more of these people are actually intertwined. Anyway, that being said, you mentioned Nobel, and the Nobel Prize. There were some announcements this last week with winners. What always interests me, when I first found out that Nobel was the inventor of dynamite. I don't think a lot of people know that, but anyway, side note on that piece. Um, but you did mention that there were some Nobel Prize announcements this week. There were actually two of them that were related to AI. And I know at least one of them, related to Hinton, was how should I say, interesting in the sense of the perception that he had, because it wasn't really focused, at least on his work, that he thought he should get a Nobel Prize for it. But nonetheless, anyway, I'm kind of circumventing around the outskirts of it. But you want to go a little bit deeper into the two Nobel Prizes, and there was actually two that were won this week, one in physics and the other one for chemistry. So you want to enlighten us on what actually transpired and who got what as it relates to those Nobel Prizes?
Yeah, it all started, Jimmy, this week with the Nobel Prize winner with physics, so where Geoff Hinton and John Hopfield, they actually won the Nobel Prize in physics for their work in the foundational AI. And I think a lot of people know about Geoff Hinton, who is also considered the godfather of even AI, but godfather of deep learning. Um, so he co-created this back propagation algorithm, which actually allows neural networks to learn from their mistakes. And these kind of and the reason why it has been given under the physics category is because these learning, they actually uses a lot of principles like energy loss and diffusion, etc., which kind of are considered the domain of physics, and that's why the physics has been chosen. But honestly, it left me actually scratching my head. Right, initially, a lot of people actually are still scratching their head. Okay, that how does it now become the domain of physics? Because then that way everything is domain of physics. In fact, everything is domain of physics, chemistry, biology, right? Even neural network, okay, kind of mimic the neuron, so why not biology? Right? So it's like this. So people are still trying to make sense out of it. But one thing is clear. And by the way, the other half of this same physics prize was to John Hopfield, who's a professor at Princeton. And then he was an early pioneer in some of the foundational work in the realm of AI. And he developed what is called as Hopfield network, which is a type of neural network that like demonstrate how the neural networks could store and retrieve pattern. So his work and Geoff Hinton work together combined actually creates a powerful AI that we see today. So that's what the physics prize. And then on the other hand, there was a chemistry Nobel, which was given to actually three of the people, and two of them were from the DeepMind, Google's DeepMind. And that is actually about how to predict the shape of a protein, which has been actually a very tedious problem. It takes actually a lot of experimentation in the past, and just takes years, right? If not months, to actually predict, and that too, the accuracy is pretty low. So Before this, it was very difficult, and they were able to do, I think, only about 170,000 proteins, although there are like 200 million proteins that exist. And the shape of the protein is important because, like, essentially the proteins are made of amino acids, which are sequences, and then you essentially they get folded, and then that's how this is called protein folding. And that's why it becomes very complex to predict that shape. But that predicting a shape is extremely important because proteins are like building blocks of life, and then they are actually used in a lot of medicines and treatment and drugs discovery and things like that. So essentially, just if you can predict the shape, you can actually do a lot more on the advanced medicine. So that was a part that Google's DeepMind was given because they created something called AlphaFold. And the AlphaFold is actually a tool now. I think they have third generation, which actually helps predict all these protein shape. And there was the other half of that prize was also given to another scientist who was actually able to create the protein, which would be actually again helpful, right? Put these two things together, and then you will find a lot of new drugs and medicine and treatments
Yeah,
actually being
and that's the profound part. It's not necessarily, oh, I got a neural network, but it's about how they're being applied, whether or not it's on the physics side or in this area of chemistry as it relates to quote unquote biochemistry. And if we can leverage or harness the power of artificial intelligence to come up with, let's say, a way to cure cancer, these are things that take obviously many years to develop in the pharmaceutical space, with lots of researchers. So if we could use AI to do that drug discovery, to do the diagnosis of different diseases or that bioengineering, that's the groundbreaking capabilities. And even on the physics side, where you mentioned with Hinton, I as we've talked about before, I'm into weather. Weather is based upon physics of fluid dynamics in the atmosphere, and we're starting to see things now even applied from the physics standpoint into meteorology, where things with neural networks and computational models, they're merging and we're able to predict things even better. So the work, as it seems like, oh, why are they getting prizes in physics, within in Hopfield? There are real world scenarios where those neural networks and models are being applied. Obviously, weather is just one of them. So to me, it's interesting. There is one other thing that I'll kind of highlight, because I was listening to, I think it was Hinton that was in an interview, and I can't remember if it was the Times or something like that. But he was mentioning the fact that, yeah, he thought it was strange that he got a Nobel Prize in physics, and I think one of the interviewers asking him about that. And he's like, there really should be a Nobel Prize for computer science or artificial intelligence, but we'll leave that to the people at the Nobel quote unquote council.
I think you're absolutely right, Jamie, that I think it would be best to actually create, and it looks like Nobel is actually finally waking up to the fact that there are many more new sciences that will make profound impact. So I think probably it's time. Um, and this is a great example of how the industries are being fundamentally reshaped by AI, right? I mean, look at this Nobel Prize. This is a great example where this chemistry prize was given because AI is now fundamentally reshaping it. It's completely pivoting the way the research is being done. In fact, the fundamental research also. So it makes total sense. And I remember, Jamie, that I think there was a few years ago I read like at MIT they were actually trying to use the AI to predict new drugs, and 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 creating these new drugs is an extremely tedious process. It takes years and it takes billions of dollars. That's why these drugs are expensive. And it may take up to 10 years actually, because you have to try a molecule, and you start with that molecule, and then you identify the short list of molecule which can probably target a particular disease or disorder, right? And then you keep experimenting, and then you learn, and then sometime at a much later stage you figure out that this molecule doesn't work. So you start with thousands, and eventually, if you're lucky, you will end up with one or two that will actually be finally successful. A lot of drugs that we know, they don't even come out of it. If you remember, there was actually, when the COVID vaccines were being developed, there was actually one track being done by, I believe, the Merck. I think Merck was trying to develop something, and eventually they abandoned because it wasn't showing the positive results. Right, so it happens a lot. And then using the AI at MIT, they were actually able to predict new molecule, new drugs that would be created. And I think they were trying to do that for antibiotics, because antibiotics is a huge problem of the high resistance being developed. And now you need to find actually more new actually antibiotic which can actually treat many of the disease, because a lot of these infections have become actually resistant to some of the existing antibiotics. So you need to keep discovering new, and the AI was able to actually suggest two new molecules and two new. So it can be profound. Completely agree. I don't disagree about the impact that the AI has made, and the level of recognition that Nobel has made. I think the controversy was only about whether it belongs to the right category or not. And to avoid that, I think it is time that we have its a category of its own.
Yeah, I agree. It's probably in due time, or time has passed to actually do that. I mean, the Nobel Prize was formed 100 years ago, give or take. So certainly a lot has changed since then.
Absolutely.
Speaking of a lot has changed, obviously we've got NVIDIA as one of the leading quote unquote companies that are developing, AI based chips, the GPUs. So Advanced Micro Devices, AMD for short, announced plans recently to kick off mass production of their new chip, the 325X. So mass production is slated for this quarter. So right now, and that is, aiming to compete directly with NVIDIA's dominance within the market. Um, what's also interesting is that AMD revealed that its next generation chip, the 350 series, is set to launch in the second half of 2025. So, July, August, sometime in that timeframe. And that is slated to focus around enhanced performance and memory capabilities over, the models, the 325 that I just mentioned. So again, competition is, ramping up, if you will, from NVIDIA. But, I heard NVIDIA's with Blackwell. I think if I had the stat right, that they've already sold out for the next year. So,
That's
yeah,
true.
not making stock predictions here, but definitely NVIDIA would be a good stock to own.
That's true. That's true. And honestly, Jamie, for the last 2 years, I've been thinking that okay, I think Nvidia has peaked now. There will be a lot of other competition, and then everybody will chip away their market share, etc. So I thought that okay, the stock has also peaked. The Nvidia has also peaked. I'm not going to buy and invest right now. But it has been like I've been missing out on that opportunity for last year because it just continues to perform.
Yeah.
Because the reality is that a lot of these shapes and etc. are still not fully ready, right? Cerebras actually is trying to give a good competition. They have a different approach. I talked about in the last episode. AMD is trying to catch up. Intel is trying to catch up. There are many other companies also who are also actually trying to do similar kind of AI chip because it's just so lucrative. I mean, and Nvidia is such a lion share that they just have absolutely no competition, and they're not even able to capture all the demand. So it's just incredible actually feel right now.
Yeah, definitely. It's certainly there's a clear leader, but others are certainly catching up. Speaking of clear leaders, I guess maybe a leader in autonomous cars. I know Tesla had an event this past week. You want to enlighten us on some of the major things that came out of that?
Yeah, that they had a movie I Robot. No, sorry. It was actually an event called We Robot. And as usual, it was a fanfare and Tesla. But three main things, right? They launched um one was the Optimus robot. And the Optimus bot is like, it's something that they are getting closer to actually start delivering. They say, I think by 2026, something will, probably, or maybe in a few years, something will be more tangibly coming out. They showcase the Optimus bot actually doing the watering the plants, groceries, doing dishes, even bartending or babysitting, and anything you want. That's what Elon said that they can do anything that you want. A few years ago, actually, if you remember, there was actually a funny event. They actually showed a person dancing in the robot suit, right? So they he referred to that. We started from there, and now we are here. And it looks cool, like they seem to be. I don't know how far they are from delivering something which will be really household useful. But maybe they will start, I think, more from the industry purpose before I think it goes into household. It could be sometime otherwise creepy, right? Having a bot. And after having watched movies like iRobot, I'm not sure if I'm ready for the bot yet, right? A full human-sized bot yet in the house.
If
But
if it
that was a
if it could, I was going to say, if it could do the dishes and do gardening, it might be worth more worth the $20,000. I think.
that is true. That is true. I think maybe laundry too, right? So I think it would be yeah, because the price wise, I think it's not like he said like it's about 20 to 30K, and similar to the car. And by the way, he said that a lot of capabilities that they've done, and the reason why the Tesla is doing this is because he said that lots of capabilities that we have built to develop the car actually is easily transfer into developing the parts. It's just that it doesn't have wheels, but otherwise, lots of those capabilities are easily transferable. Um, but yeah, it was actually the most promising part of the event, because some of the other things were a little bit, maybe more in the future. The other announcement they had was actually Tesla's robotaxi, and they showed a lot of different things as well. But we're just going to cover the main one. Robotaxi. They It's an electric robotaxi, of course. It's called Cybercab, and it's set to launch around 2026, and with the price under $30,000. And it's designed without a steering wheel, so it's not like a car what we have today nowadays that can still autonomously drive. But this one is designed absolutely without a steering wheel, no pedals. It's just a two-seater vehicle with butterfly, wing doors, and even the wireless charging, by the way. And it has Tesla's full self-driving system. So it's part of the Teslas. They are building an autonomous ride-sharing network, but you can also actually buy it. And their, I think, cost in the operation is going to be about 20 cents per mile. That's what is predicted. And
So how
Elon
does
has
it?
promised big things.
So how does it work? Yeah, I'm imagining like an interface like an Uber. Like, hey, I want to be picked up here and dropped off there. Is that like the concept on this thing?
Yeah, I think it will be voice operated. Basically, you will just get in and talk about, hey, let's go there, right, or whatever the address is. And depending on how you want to use it, right? I mean, if it is part of the ride sharing, then it arrives and you go. But he also said that it will be available for individual purchase as well, so you can have your own, and then you can customize it much more for your own taste, actually. um,
I'm thinking about like business ideas where you could create your own fleet of taxis without you ever having to step into the car. They're just off doing work for you, and you make money.
Absolutely, absolutely. And I think, Jamie, I think the most important thing is that from a convenience and other thing. Because I mean, to be honest, like I like to drive. Actually, I don't mind
Me too.
driving. I like driving. I feel what will I do if I'm just sitting, right? I mean, yes, you can browse on but I like to drive. So driving is a pleasure. I'm not ready to give up completely. Um, but I think
And I would have to be. I was going to say I'd have to be very convinced on the safety side of this.
Mm.
I don't know if I'm personally ready yet to just get into a car with no steering wheel, no pedals, and just be like, all right, take me here. I think we've all seen some of the footage and crashes. So when is this supposed to come out? You said like next year.
2026.
So yeah, it's about a year and a half away.
Yeah, but
We
a
got
lot
to
of autonomous are still anyway riding. I mean, if you go to the Bay Area, they are anyway making the round.
yeah.
So I think the question is that, and to be honest, yes, you're absolutely right. I mean, there have been some incidents on the road, but then there's another aspect of it, Jamie. Like from a safety point of view, just this week actually, there was actually a session in my daughter's school, and she was telling me about that. There is, I think, a kind of a framework called semi they have done. Actually, there was a girl, I think a few years ago, She was supposed to be picked up by a rideshare, Uber. She called the cab after a party. Unfortunately, she went in the wrong car altogether, completely. And it wasn't even Uber's fault, because she actually got into a wrong car. She didn't ask, and the car was, of course, it's some black car, which was actually, it had some predator in it, essentially. And he locked it had a child lock and everything, and she just couldn't get out of the car, and she was found dead later. So it became a huge news. And then we also discovered some facts, like, the Uber itself has actually reported several of the casualties. Okay. So this is actually another aspect of safety, because from that point of view, it is far more safer getting into this car when there is nobody, and you don't have to doubt somebody's intention, right? I mean,
Yeah, as long
that is
as the
another
self-driving software and visualization and everything that it's relying on as it relates to AI is working, I see that point. So
yeah.
you take out a third party who you don't know who you're getting in their car, and if this robo the Cybercab, sorry, if that is fully autonomous without a third party who you don't know, then yeah, theoretically it's safer because you're not jumping into somebody, you're not jumping into someone's car without you knowing them. So I could see it from that point.
Exactly. Because I think the most dangerous thing that we do, in our daily life, is actually getting into a stranger's car, right?
Oh no, I
Or
think about that all the time when I take Ubers. I'm like, I don't know
exactly.
who you are.
Exactly.
I'm putting
all
my
all
life
we
in
have
your hands. Yeah, I'm putting my life in your hands while I get into your
exactly.
car or truck.
And all just because of that app that somebody has developed. But it is the power of that trust, right? I mean, somehow
Yep.
we have placed that trust in the Uber and the rideshare and the lifts, and then we get into such stranger's car. We would never do that otherwise, right? I
I
mean,
know.
it's
Yeah.
like such a transformation, right? And the other dangerous thing that we do is sleeping in a stranger's house, right, through the Airbnb. That's another thing. So I always get a little bit nervous whenever I have to go to an Airbnb. But of course, that trust has also started building up. But these are two most dangerous thing, and unfortunately, incidents still happen. So I think
Yeah.
from that point of view, robotaxi, it could be a good option for those folks. The other thing is that they also actually released, by the way, something called Robovan. Robovan is essentially a much larger vehicle. It can carry actually up to 20 passengers. It looks pretty sleek. Okay, it looks pretty good. Cybercab also actually looks good. And initially, the cyber truck, I don't know if you are in the camp of somebody who likes Cybertruck, Jamie.
It's
I'm not.
interesting looking.
It is creating a lot of the divide in the society, right? People
Yeah,
either hate it or love it.
yeah. The first time I saw it on the road, I'm like, "What the heck is that?" But that's
Yeah,
cool. So it's basically you've got a personal car in the cyber cab and just a larger version, the Robovan. So I can
correct.
certainly see the Robovan. When you think about commuters, especially in high traffic areas like commuting into New York or San Francisco or wherever it may be, those types of things would certainly come in to be very beneficial to the commuters. I could see it for school, like picking up kids to go to school. I mean, same concept, the same idea, or even school trips. So yeah, definitely keep an eye and a pulse on it. I think it is the wave of the future, whether or not we like it or not. And I think back to the Jetsons, going back to the cartoons I used to watch when I was a kid. So, same concepts, they're becoming a reality. Anyway,
Absolutely.
from cars, let's talk about some things as it relates to pure technology. So this one's been out for a little while, but I'm not quite sure if people actually really truly understood it. This was announced back in August from not only Microsoft, but OpenAI. There's a concept around batch APIs. The reason why I mentioned this, a lot of people are very focused on how much is this going to cost when they run against a quote unquote a large language model. So the batch API is literally what it sounds like. It's meant to handle large scale and high volume prompts to be able to process that efficiently and bring back the results. So if you think about it, it just processes a group of requests. It's not instantaneous. There could be a 24-hour time turnaround. But again, so you got to think about what your use case is. But the real benefit here is it costs 50% less than the standard, direct integration with a large language model. So your applications, you send a batch of requests rather than just one at a time. So if you're thinking about cost conscious applications that can fall into this use case, definitely something I would say take a look at.
Mm. So this essentially cannot be used in a call center kind of settings, but I think everything else, which
Yeah,
kind
and
of
think about it like doing summaries. If you don't need those summaries right away, and that's a great example where if you
Mm.
could wait 24 hours on that, and you do quote unquote run these things at night. I think back to my days of like running batch processes to load a data warehouse. I'm going back circa like in the 1990s, but you typically ran those things overnight. People still do it, and then you're ready for your data the next day. Kind of the same concept. Let this thing run overnight, or how long it actually takes, and then you get your results and do whatever those results are slated for. So it's a great way of saving cost if you if you don't need things instantaneously.
Yeah, 50% cost saving is actually a good figure.
Yeah, and you think about it, the models are getting cheaper and cheaper, but you want these two different ways of how you're interacting with it. So just a great little tool to keep in your arsenal as it relates to cost savings.
Yep.
So one of the other things I do want to mention, and it's kind of pseudo related to some of the Nobel Prize stuff that we're just talking about for chemistry / related to the medical field. So Microsoft, if people don't know, Microsoft actually has industry clouds. So there's a FinServ cloud. There's a cloud for sustainability. There's also a Microsoft cloud for healthcare. So within that healthcare quote unquote cloud, there's many different components or facets that Microsoft puts out. Maybe we'll cover that in depth one day. But what was just recently released are new healthcare AI models that are very specific to different tasks, and these are focused around multimodal AI tools for medical imaging. So there's 3 different models that were just announced, and again, these are in partnership with NVIDIA and Page AI. So again, we talked about NVIDIA and the horsepower there, but one of them is called Med Image Insight. So this is a embedding model that enables very sophisticated image analysis. It's very much, if you think about it, in the way that people might analyze radiology or dermatology or other types of modalities. So just basically image analysis. There's another related one called med image parsing. So this is for precise analysis of things like X-rays, CT scans, MRIs, or things that relate to pathology. So you think of it this way, like how long does it take a radiologist that's looking, or an X-ray technician that's looking at the output? So if you're able to, and I can think of a couple different ways. One is, just speed this up because now I can run through a lot of different scans. But if I also want to augment the things that X-ray technician is doing to get a quote unquote second opinion, that is one way as well that this medi image parsing could be used. One of the things too, and I mentioned like X-rays, this will be a trivia item, like what's the number one X-ray that is used? It's actually chest X-rays. And it's the most common one for radiology. So there's another model called CXR Report Gen, which stands for Checks X-ray Report. This is allowing, again, these X-ray technicians to use these multimodal models to look at X-rays for the chest, highlighting things that the AI model can find. So it's fine-tuned to chest X-rays. So again, these are just advancements that are moving forward what we're able to do in the medical field, and leveraging these AI models. So kind of go back to a nod to what was mentioned before around neural networks and how this is changing the way of what we're able to do, and some of the Nobel Prize pieces around chemistry. This is obviously not chemistry related, but it's radiology and being able to look at things. So again, it's how are these models being able to be used in, at least in this case, the healthcare or medical field.
Yes, I think anything healthcare, life science related AI application excites me. It can help literally saving the lives. This is awesome.
Yep. So I guess moving into another set of topics, I know we usually cover off, at least in some cases, a company of the week. Do you have a company of the week that you want to highlight?
Yes, absolutely. A solid company, actually. Sorry, pun intended. The company name itself is actually Liquid AI. Um, so, so this company, Jamie, is actually a spin-off from the MIT. Bunch of MIT folks have actually started that. I think there are four co-founders. Um, I think Ramin Hassani is a CEO and co-founder. Daniel Eras is also part of this. I think director of the one of the unit at the MIT, and they have actually created. So essentially, as we know, the transformer models that are used in the LLMs, they have models what they call as LFMs. LFMs are liquid foundational models, and they are saying that they are fundamentally different from the transformers. They are also Gen AI models, but they work differently. And the part that you can think about is, for example, the neural network. They also use the neural network, but they have invented something called liquid neural network, and their models are based on that. And liquid, what essentially that means is that it's a continuously learning. So not just during the training, these neural networks learn, they can actually continue to learn even in the real time. And that's why they also refer them as like more liquid. And their liquid LFM are actually based on that liquid neural network pattern. So one of the things that they have done is that the way they have created a memory footprint. So their models, they claim that actually have a very less memory footprint. So as you go more on the context window, the memory footprint will be much smaller compared to the LLMs, for example. So it can scale better. Right now, they actually only support only 32K, so you can't really prove that out. But that's what their promise is. So it's like another take on the transformer architecture. This is not a transformer architecture. Like the companies, other companies have also done something similar, like Jamba, etc. They've tried to combine the different design. In this case, they are also actually doing little slightly differently. Gen AI models, they can do the same thing, the text, audio, multimodal, and all those kind of things, but different architecture. And as per their own benchmark that they have published, it actually performs much better than the LLMs. Now, right now, they have actually only done that for a certain smaller size, more like the SLMs, you can say, or the medium size models like the some of the Mixtral and Gemma and the Phi and all those kind of range. Actually, they haven't they're not comparing them yet with the frontier models like the GPTs, etc. at this point of time. But they claim to be actually much more efficient in terms of the memory footprint, so that they can scale better. They will have, that's why, probably less cost, and they will be able to also actually do more learning in the real time than actually just with the training cutoff. Okay.
I'd be interested to see, because this is certainly a different architecture. If they're not using the transformer model, how is the language understanding? I know you mentioned some things around performance, but like how is the MMLU, and some of the other benchmarks that are typically done against the LLMs and small language models? How does that compare? Have you seen anything with those benchmarks yet? And what I guess another question would be, if you think about what this new model or this, the LFM, are there use cases that it's really good at, and maybe some use cases that shouldn't be looked at to use this model?
Yeah, actually, good question, Jamie. So this model is actually they they're good in, for example, right now they're actually good in like general and expert knowledge, mathematical and logical reasoning. They can do some efficient and effective long context tasks, and right now they're limited in the language in terms of the English and some language capabilities in other language like Spanish, French, German, Chinese, Arabic, Japanese, and Korean. So not too many, less than 10. What they're not good, in their own words, is the like zero shot code tasks. So for example, it does require some, because they also learn on the fly as well. They do need examples. They can't do very precise numerical calculations. They can't do time sensitive. So I think the latency is a bit of a challenge. So right now, like, it's more of it's still a research thing. They are still
Mhm.
seeking the partners to actually come and work with them, and together they will develop things. And of course, some of the things like counting hours in the word strawberry, which has become like a
Yeah.
litmus test of AI. That also actually they say that it can't do those kind of things. So they admittedly it is not good in everything right now, but they claim that it will be actually reaching to that level where it will actually outperform all the LLMs and everything. So that's what their um, that's what their promise is. Now, at this point of time, they also have like sought some funding. So they have like just recently they actually got some new funding, and actually end of this month, I think in just about 10 days, they will be actually revealing some more products as well. So we will keep an eye on what they will do, and if something interesting, we will bring to our audience as well. um, but at this point of time, they are essentially another competition with a different kind of an architecture, and a promise that okay, their models will be more efficient. They can actually handle better context, because they believe that the transformer actually has a problem in handling those kv, like key values storing and all those kind. It can't fit it. So their premise is that okay, their model can actually, their architecture can fit those key values as you scale up much better.
Hmm. Maybe for a different episode or just some my own research, it'd be interesting to see how this compares against the reasoning models that OpenAI with O1 has put out, because that's obviously in a model class all by itself as well. So bottom line, I think advancement of models as it goes forward is important and is good, because it drives differences in what um, can be done with the models themselves. So I see that you're sharing some stuff.
Yeah, actually I wanted to just to quickly show, right? I mean, these are some of the benchmark that they have actually published. Since you asked about it, this is what their promise is, that and right now you can see, right? I mean, as the billions of parameters, as the number of parameters increase, the performance, how it actually improves. So what they're saying is that their models are actually entirely into a different band altogether. 1.3 billion, they have like a three parameters right now. 1.3 billion, there is a 3 billion, and there is a mixture of expert 40 billion, but at one point of time it only uses much lesser, I think probably 12 billion or something. And it outperforms particularly on the mmlu, etc. They've given actually other benchmarks as well. So you can see that here on the other benchmarks how it actually performs compared to the other, but you can see that right now it's all in the realm of these SLMs. They are nowhere close to any frontier model right now at this point of time.
Okay, no, it's something it's good to know, and like part of what we bring here is insight onto some companies that you should pay close attention to as we move forward. So
Absolutely, absolutely. I think we just want to bring all the different kind of how the AI, how the different players in the AI field are emerging, how the different players are actually using AI. So the idea is to like open those doors of mind to think about how everybody is using AI in a different ways and how they are playing an important role in the AI itself. Okay, what else do we have, Jimmy?
yeah, so I know that on I guess it was maybe the last episode or maybe the last two, we talked about a couple of different topics. One was Canvas, which is the part of the new UI of ChatGPT. So I'd like to actually demonstrate it. And just a kind of quick reminder of folks. So this was something that is a new feature of ChatGPT, and it's really about how you as a user interact with it. And it's called Canvas. It spawns off a separate workspace for writing and coding. It basically makes an interactive feel for working with the output. And I can tell you, I'm a paid user, which, by the way, you need to be a paid user right now because this is still beta. So if you're, got the free version of ChatGPT, you're not going to see this yet. But it basically allows a user to interact with the output. And I use it a lot previously, ChatGPT, to do development of code. And if you've ever done that, you had to scroll up, where was I? What was the last version? Canvas actually rewrites things in a separate side-by-side window. So probably best for me to just show it. So that's what I want to do. So let me share out my screen, and I'll take you on a quick little tour. So
Canvas is great. Actually, I love that. This demo would be great.
So I'm in my ChatGPT, and like I mentioned, I've got my own paid version. So if you're not on that paid version, you're going to see just like the regular ChatGPT 4. It defaults to that model, but you see something that says ChatGPT 4.0 with Canvas. This should literally be your default mode if you have it. There's no reason not to use Canvas. What I found interesting is that ChatGPT will automatically flip over into Canvas mode, like actually showing the side by side, depending upon what you're asking of it. You could also force it to go into Canvas mode. I have a couple of prompts, so I'm just not going to type all this stuff. But if I say, open a canvas for coding, it will actually start that. So it's opening up a coding workspace and then allows me to work in this canvas. I'm just going to start a new one. So here's an example. And these are straight off of the OpenAI website. So you could use that. So write a React application that has a login and a password, then a web page with a menu suitable for online shopping. Actually, this one's not on the OpenAI site. I just actually created this my own. So what you can see here is it not only is it building the application, right? So there's my code, but I have now, there's a couple of things I want to point out here. There's these widgets, and it's different if I'm doing code-based and or if I'm doing writing-based things. So here's one that I love, and I'm sure a lot of people are going to love this as well. I could tell it to add comments. So just by quickly creating or clicking on this button, you're going to go off and actually add comments into it. Now, what you notice what it's doing, it's not, writing another series of code, and I would have had to scroll up. It's actually doing it in line. Now, what's also important here is this is editable. So I could, write in my own comments or do whatever code I want directly in line. Obviously that doesn't make any sense for what I'm doing, but I'm just adding a comment into that. But I can directly edit over this information, and then it recognizes and understands that. Same token, I have this interface. I could say, make a new function to calculate total sales tax. So it'll go off and try to figure that. And again, what you're noticing here, it's just redoing or recreating the code for me, and then it's building it up, and it just created that new function. There's other things in here too. I could add logs. I could fix bugs. So these are going to be things. It's basically almost like a starter prompt, but it's going in and aligning to what I have here. And then I could port to a different language and then do a code review. So this will actually review my code. So this is just a great interface. Now, probably people are thinking this kind of looks like Claude artifacts. Not exactly the same. It's this notion of side by side. I would, some people say, well, this is stealing from Anthropic and Claude and its artifacts. Actually not. I mean, you could go back and think about some of the early things that OpenAI had put in to, building GPTs. You had this like side-by-side windows. So the other thing too is the Claude artifacts does things differently. They actually have a way of actually running the code inside of the environment. So, different scenarios, different uses. I'm going to go and create a new chat just to show you a scenario where it's based upon writing. So I'm going to use this one, write me a blog post about why a strawberry is a pseudocarp. And I had no idea what a pseudocarp was until I actually ran this. So again, here's that side by side. It's creating the blog post for me. And again, once this comes back, I can interact and tell it to change things. But this is a full editor. Let's say if I didn't like that, and I added my own words here. Again, I'm just updating it directly. Now, if I tell it to, here's a great example. I could say, well, what's the reading level that I want? Well, right now it's in the middle. But if I said, well, this should be college level reading, and it goes and execute it, it'll change all of this wording for me and doing it at a different, quote unquote grade level or reading level. So again, I go back to, these are sort of like starter prompts. Yeah, I could have done the same thing in here just by saying, change this to be a college level or high school level reader, but I have these widgets, and then suggest edits. This will go off and suggest edits into this, where I kind of equate this to like Word when I'm thinking about a comments in Word and someone makes, well, here's the suggested edits. And I can look at, well, what does ChatGPT think should be changed? Here's that suggested edit. And I could say apply, and then it automatically applies it to that one section. And again, you can see how it's doing this. It's rewriting it in line for what's already there. So much more user-friendly. I love this new interface. So that's the Canvas real quick.
Awesome. Yeah, I mean, I think this is more like like in one of the key differences. For example, if you're writing a code in Anthropic or like rather Claude to build a video game, for example, right, a Pac-Man, let's say, it will the artifact will actually show the game itself, how it renders and how it gets played. But in the canvas, you will actually get the code itself, right? Not the rendering of the video game itself. Is that right, Jimmy?
Yeah, that's exactly right. Yep.
So that's the key
So
difference.
I do want to draw one other parallel. And again, I know that we talked about the notion of Microsoft's Wave 2 for copilots. That introduced the notion of being able to create agents, which, peel that back, it's really like creating a custom GPT. But what also that Wave 2 brought in was this notion of pages. And so this is actually an agent. And I've already asked the question of the agent, but what you can see is I told it to edit it in pages. So this brings up a very sort of similar interface between what I just showed you in Canvas and what is here in pages. Now, it's not exactly the same because, again, those widgets that I showed you, like do comments or change the reading level, I don't have that ability in pages, but this allows me to work with other people and share this out and then, edit directly in line. So you kind of get the sense of Canvas inside of Microsoft Pages that, at least in this case, is aligned with the M365 Copilot, or what now we know called BizChat. So I wanted to just show that because I'm sure people may have run into this already and or maybe don't even know about it. So I figured I'd share that real quick. All right, so that's that one demo. I do want to bring up one other quick demo for everybody. And this one was, I think, the last episode that we had. I unfortunately was not able to attend that one. I was actually in Florida for a family function, but I saw the episode that you did, and in the beginning where you were chatting with, I'll call it maybe the Jamie replacement, where you had a real-time audio. So those that maybe didn't see that episode or don't know, OpenAI and Microsoft simultaneously released this ChatGPT real-time API, and it's meant to be a interface basically taking ChatGPT and doing voice, but not actually having to do any prompting with it. So what I'm going to share is how to create that, because I believe, Shadab, you just went through and used the quote unquote, what I'll call maybe building block to use it directly, but didn't show how to create it. Correct?
Correct. Yes.
Yeah.
We didn't try to put things together. I was just here
Sorry.
is a special guest in so
Yeah.
just an output.
Yeah. So so how was that done? So from Microsoft, we have something called Azure AI Studio, which is the way that we build capabilities, and you can look at different models, whether it's OpenAI or others, start to do things in playgrounds, actually build code through prompt flow, tons of stuff inside of Azure AI Studio. But one of the things that we just recently enabled is the real-time audio, and this is the preview. So you could see here, this is that playground. One of the first things you need to do is you need to create a deployment, similar to deploying a GPT-4o or GPT-4 or GPT 3.5 that you may have done, last year. You still have to deploy a model. In this case, it is the GPT-4o real-time preview. And again, this only came out, 10 days ago or 13 days ago. So I've already deployed this real-time model. Now, you want to give some instructions, quote unquote, a system message or a persona to this. As I've kind of mentioned many times over, I am a weather buff. So trust me when I say this, this is a persona that basically says, hey, this is going to be a podcast on weather. All right. So I'm going to save that. So you could pick several different voices. I've used Alloy. I don't know how to actually pronounce the right one. There's parameters that you could change for the voice itself, like how long or how many max response and tokens and what's the temperature. So this is very similar to the things that you have in GPT-4. Now, where do things differ? Well, instead of me typing stuff, this is where it uses the microphone to go directly back and forth, and it gives you the answers rather than in text in voice. So I'm going to make sure I'm not going to do tons of this because, again, I already know that, Shadab, you spent probably like 20 minutes interacting with the real-time audio in the last podcast. But tell me about a recent Hurricane Milton that impacted Florida.
As of now, there is no record of a Hurricane Milton impacting Florida recently. However, it's possible that this storm has not been widely reported yet, or it could be forming or forecasted for the future.
There actually was a Hurricane Milton just last week. Can you double check on that for me?
I've double checked, and currently, there are no recent records of a Hurricane Milton impacting Florida or any other region.
Of course, I just did this a little while ago, and it did bring that back. Trust me. I'm going to ask a couple of other questions. How many hurricanes are typical in a current year in the Atlantic Basin?
On average, the Atlantic hurricane season produces about 12 named storms, of which 6 typically become hurricanes.
Okay, thanks. How does this year compare to historical averages as it relates to tropical storms, hurricanes, and/or major hurricanes?
To provide an accurate comparison of this year's tropical storm and hurricane activity to historical averages, let's look at the data from this year's Atlantic hurricane season so far. As of now, the 2024 Atlantic hurricane season has seen 15 named storms.
So you kind of get the idea. I mean, you're just interacting with this, and like you did last week, Shadab, it's a great way. And the use case of this, you think about call centers, this is a great scenario. So, as long as you train the model and introduce something like a RAG pattern, and that's a tee up for something that we're going to talk about very, very shortly. But if you provide, quote unquote, data that's relevant to your company or the things that you're looking to do, and then have an interface that leverages this real-time model, now you're able to do things like that call center without actually having a human to interact with the person. We could talk about the ethical things of doing that, but different story, different day, different show. But anyway, I wanted to show the real-time audio and how it was set up, because if you were listening to last week's episode, you saw it in action, but you didn't know necessarily how to build it. So anyway, that's all for my quick demos here for today. Shadab, I think you're on mute.
Oh, sorry about that. It had to happen once. Um, so, I can tell you, Jamie, this advanced voice capability is amazing. My wife and I, we speak other languages as well. Some of the Indian languages, and not very common at the world level, but it was actually able to converse with us in those languages like Malayalam and Urdu, which are our native tongues. And it was shocking. My wife was shocked. I asked it to, tell the recipe of making biryani, for example, and and it was actually amazing. So, um, what is amazing is that how these models in real time they are able to switch between languages so easily, right? I mean, that's why they feel so natural. Like how at home we switch languages easily. So it is incredible, actually, model, no doubt about it.
So I alluded to being able to do the RAG, or retrieval augmented generation, with a model like the real-time API model. So there's a new vocabulary that's coming into generative AI, and that's around VoiceRAG. So we have RAG, we have Graph RAG, now we have VoiceRAG. What the heck is VoiceRAG?
Yeah, actually, VoiceRAG. So, of course, with the real-time advanced voice capability, I think naturally the next question will come is that okay, so how do we augment these models with the organizational knowledge or any document that you want to throw into it, which it has not been trained onto? And typically, a baseline RAG is rather a little bit easier. You have a model; it makes simple. Just it connects with the for example, Azure AI search in our world, or some other search, etc., that you can make a connection to, and then it will pass the query, um, and then the search will actually retrieve the documents based on from the repository and based on the permissions also importantly, and then it will essentially bring the results back to the model, and then model will essentially synthesize a response based on that. Right now, what happens in the case of the voice, for example, with these capabilities? So slightly different design pattern. So what happens is that these models actually will they have something called function calling, and function calling has been actually a feature in the GPT models available. It is particularly useful for the agentic framework. Essentially, it's a function like you're calling a function and it will doing a certain task and then bringing the output back. So there are two functions actually involved in the voice RAG. One is that it will make a function call and it will go to the Azure AI search, for example, which will go and then just like a typical a regular baseline RAG, it will retrieve the results based on the query. So, for example, if you make a query that, okay, um, what is covered as part of my health policy at the work? So, it's going to go make that query through the function calling to that Azure AI search. Azure AI search will look into the policy documents. It will find the relevant content from it, and it will then pass the result back to the model. And then the model can actually again synthesize the response and then transfer it back into the audio return. But in the baseline RAG, generally what happens is that you also get the citation because it is returning the citation as well, that exactly where it found those reference in the referred document, so that the model, when you interact, the model can also actually show you, the LLMs can show you here in this particular link, it found that reference. So what would happen in the voice rag? In the voice rag, you have to actually make another function call and then use something called report grounding. And that report grounding actually gets you that citation as well. So combining the report grounding and the function calling that you made for the just the results, now you have to assemble the similar kind of efforts where the model is actually talking back to you in the voice, but it is also actually presenting the links that it has found, which has a citation, which has essentially the content that it is actually relaying back to you. So little bit, just a little bit different design pattern, but it is actually possible to show the similar kind of effects. In fact, Jamie, this actually VoiceRAG was published by Microsoft, and let me see. I can just quickly flash the design that they have actually come up with to show that okay how it can actually quickly work. Okay, I'm just gonna show this screen so that okay. So this article was published in the tech community blog, and we will provide this link in the show notes so you can see this voice rag published by Microsoft and how does it actually work. There's a video demonstrating the effect, and then it will show you how this architecture works. So the input is passed, um, whether it's a microphone and speaker, it has to be back and forth. It gets passed on to the backend. The backend actually does all the RAG authentication, instructions, configuration. It uses the model to make the real-time API that you just talked about, and then it will make the function calls. The function call will actually go and retrieve the knowledge using the Azure AI search, and then it will bring there will be another function call which will be for the grounding, and then it will also bring those results back as well. Once it has brought everything back, both of them will be combined and then presented in the result, and that results you can see in this video which we are not playing right now, but that is available. And this link actually also explain how does it work, right? Function
Yeah.
call, etc. And there is a specific step they have recommended. This is important, that there are 3 steps they have recommended in the design to follow to get the best results.
So what's good is that this is not a radical shift in terms of a pattern for RAG. I mean, it still uses Azure AI Search. You have to build an index that grabs that back. So, this is applying techniques that you probably already are familiar with or maybe have already implemented. So it's just an evolution in step with the models and its capabilities. So
Yeah, and it is good to see that there's so many different RAG patterns that are emerging now. Voice RAG, graph RAG, agentic RAG, and all those kind of things. Maybe Jamie, you should show actually the all the different patterns of the RAG that are emerging, just as a summary to our audience. It would be good to see how the baseline RAG has expanded into so many different flavors of RAG now.
it sounds like a topic or a whole show we could devote just to RAG.
Exactly. Um, Okay, and one more thing I have, Jamie, to cover, which is actually about the trivia of the week. And trivia of the week is actually about the adoption of the Gen AI. So there was actually paper that was published, and the paper title is "The Rapid Adoption of the Gen AI," and it actually gives a glimpse into how the Gen AI is being adopted. And it has been written by 3 authors, reputed institutes like Harvard Kennedy School and Vanderbilt University and the Federal Reserve Bank of Missouri. So what they've done is they've actually used the survey results, and they use from survey results that Qualtrics does. It's a commercial survey provider. They have 15 million members in the demograph. You can choose the different demograph that you want to survey. They do a kind of a real-time population survey, RPS, and then you can define like which demograph that you want to reach and how many you want to do, and then some of the novel question. They have a ongoing running kind of surveys, but then you can also include some new questions as well, which they do time to time. For example, working from home or interstate migration during the COVID wave, etc. So they include those questions as well. On the other hand, they also have a long-running list of questions that are permanent. So using that and using the typical survey methodology, they actually did a survey on the GenAI adoption. And here are some of the important things that they found. One is that um, in the 18 to 64 years of age range, 39% of adults have already used the GenAI. 28% are utilizing it for the work related tasks, and about 11% are using it daily for their job. And this study highlights the rapid adoption of the Gen AI and it compares it to the personal computers and the internet. And the thing is that what they have concluded is that the Gen AI is actually a much higher level of adoption, even double in some of the cases compared to the internet and the PCs, which kind of like had exploded in their usage and adoption. So much so that, for example, they talk about um, the when the PCs and the internet actually that they came out, it was um, like after 2 years. So what they did is one of the things is that they actually tracked not just the invention of these technologies, but a mass market launch. So, for example, for the Gen AI, they have considered ChatGPT as that pivotal moment where it was considered a mass market launch, and now from there on they are actually tracking it. So it's not like the when the first paper transformer was written or things like that, but a mass market launch. Similarly, for internet, they actually identified a mass market event, and same for the PCs. And then from there on they're actually tracking it, because adoption really matters once there is a mass market offering. So what they found is like the Gen AI is like 39.5% adoption rate after 2 years of ChatGPT, and compare that with the 20% for the internet after 2 years, and then 20% for the PCs after 3 years. So Gen AI is actually almost double the adoption rate, number one. Um, and it is driven by the faster adoption of Gen AI at home compared with the PC. So PC was actually, of course, one of the important things is that the PCs were actually expensive. So not everybody could afford immediately. And most people actually started using that at the work. But in the case of Gen AI, actually more consumers are using it because of the lower cost, and they're able to actually use that at the home compared to the work. So that's one of the reasons that it is actually much faster adoption rate. The other thing is that the Gen AI is also actually more common among the younger, more educated, and higher income workers. In the case of the PC revolution, what happened was that actually it the PC revolution actually led to some market inequality as well. And because computer was actually substituting the middle skill task while complementing high skilled labor. In the case of the Gen AI, actually the high skilled laborers are finding it more of, like bit of the substitution. For example, codings, right? It has become a little bit difficult right now because a lot of the coding jobs, the high performing computer jobs, etc., are at more of a risk compared to the blue collar jobs. Um, but there is also a divide in terms of the usage. They find men are 9 percentage points more likely to use Gen AI at work and 7% more likely to use it at home. In contrast, the PC adoption was actually driven more by women. It was more common for women because the women were also actually doing a lot more word processing and the typewriters kind of job. So they were a lot more in the administrative, and the PCs were actually first started to be used a lot more in the administrative positions and occupations. So there is a bit of gender divide as well when it comes to the adoption. They also found that the larger firms, the big firms, are actually more likely to have adopted Gen AI compared to the some of these smaller firms. Um, Importantly, also they found that okay, the previous wave of AI was actually much lesser in terms of the adoption. Like only 3% of US firms had adopted predictive AI tools between 2016 and 2018. So much lesser. It's just the Gen AI, which is a new wave of the AI, which actually is really driving the adoption. So some I would recommend going that. This is a massive paper. It has a lot more details. Great read. Definitely refer to it. And the paper title is The Rapid Adoption of Gen AI. And that's it in this section, Jamie.
Sounds good. No, very fascinating. It's, the rapid rise of the use of Gen AI and its expansion across different sets of people, economic. It's just very fast as compared to other things. So good trivia. Might show up on Trivial Pursuit one day. We'll see about that. So anyway, want to thank everybody for sticking with us at this point in time. I know these episodes sometimes can run a little long, so thank you again for making it this far. If you're still listening.
Yeah, we have given up trying to conclude these episodes in less than 30 minutes. It's just not possible. Not our fault, Jamie. I'll blame the AI world. They just keep doing things. So,
very true.
Yeah.
All right.
But it was great again talking with everyone, and see you soon again next week.
Have a good one. See you.
Bye, everyone.